In this class, I'm going to introduce you to a concept which is very commonly met and encountered in research articles, somewhat controversial and sometimes not very well understood. And of course, this is the concept of the power of a test. Now, this has nothing to do with Superman or Superwoman being able to shovel snow very quickly, although sometimes I do wish I had one such person to clean my driveway. But it has something to do with, of course, with the whole process of hypothesis testing. So let's see what is the idea we're looking at. When we do a statistical test, we're always asking the purpose, the whole point of doing a statistical test is to collect data, and then we ask, do the sample data provide enough evidence to infer a difference in the population? Remember, we have two hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis means, well, there's no difference. The alternative, and is the one that we assume in the calculations. The alternative hypothesis says there is a difference. Then we look at the sample data. If in fact there is a difference and the difference goes in the direction that we thought was going to go, if there is such a direction, then the p-value usually ends up being a low p-value, and therefore we can conclude that most likely, or likely to a certain extent, the difference that we have seen in the sample is due to a difference that exists in the population, and we make that inference. Alright, but before we even jump into doing all this procedure of designing the experiment, collecting the data, computing the p-value, and so on, we need to ask a very practical question. So before we start to even plan for everything, we should ask, if there is a difference, assuming that there is in fact a difference, is our test capable of detecting it, of identifying it, right? Because of course, if the test that we plan to implement is not able to identify the difference that we think exists, then what's the point, right? So there's no point in collecting data if at the end we're not going to be able to make any inferences from the sample to the population. So it is this question that we're going to address. And notice, I'll come back to this, but notice that we need to do this before we even start collecting the data and doing the test and so on. So what is the definition of power? Of course, it's a definition done in terms of probabilities, just like for the p-value, but it's a bit of a different probability. So the power of a test is the probability of achieving a significant p-value, whatever that means, normally 0.05, but whatever that means, assuming that the alternative is true. Okay? So what that means is, now we still do the computation of the p-value assuming the null hypothesis is true, but if the alternative is true, if there is a difference, then we're likely going to see that in our samples. Well, what's the probability that we are going to see it to such an extent that we're going to conclude that yes, there is a difference? We can make the inference. Okay? So, another way to put it is, if there is a difference, how likely is this test to detect it? Okay, so that's what we're really after. And once again, the point is, if we don't have enough power, if the probability of seeing a difference that we hope exists is too low, then probably we're wasting our time, right? And probably our money and everything else. So if we find out at the beginning that the power of our test is too low, we may decide to wait for richer times when we're going to have more resources, better tests to do it. So how do we analyze this? Well, let's start by looking at the factors that affect power so that we can try and figure out what to look for in order to analyze and identify how much power a certain test has.